earlier, when I first relocated to MIT, I worked together with a colleague. His name is Christopher Moore. So at that time, he and I used, at the time, a very cutting-edge technology called optogenetics, which is not using external sensory stimulation, but rather use a rather invasive way to drive nerve cells to fire, to force them to fire at a certain frequency. This technology actually was initially developed by Ed Boyden when he was working together with Carl Dassaras at Stanford University. So we used that, and then we realized that when we manipulate a particular type of nerve cells known as the PAP albumin positive inhibitory neurons, when we particularly activate these neurons, what we get in return is this very fast spiking activity at the gamma frequency. So my lab ever since have become very interested in this gamma frequency firing of nerve cells, and we wanted to know really biologically, whether this gamma frequency waves, because when the cells, when many nerve cells they fire together synchronously at a particular frequency, they create waves, so-called brain waves or oscillations that you can actually detect using various different electrophysiological methods. So then a few years later, we wanted to study this gamma waves in Alzheimer's disease, and especially we wanted to know if we can enhance gamma waves in Alzheimer's disease, whether it has any meaningful effects. So a former graduate student initiated this project, and then we realized that it has tremendous effect. She used this pattern light initially, together with Ed Boyden and Emery Brown here in our department, and then we realized that when we enhance this gamma waves using light flicker stimulation, we can meaningfully, very significantly reduce amyloid levels in the brain of mouse models. So this whole line of project started there, and then after that, we subsequently identified that using gamma sound stimulation also can engage nerve cells in the brain and force them to fire at the gamma frequency. So with that, Cognito Therapeutics licensed our technology, and then they developed clinically conducted phase 2 trial and saw very, very promising results, like a very meaningfully kind of attenuated brain volume loss and memory impairment. And in fact, here at MIT, we also have a team of researchers working with human subjects, and we also conducted a very small-scale clinical study on early-stage Alzheimer's subjects. And we also found with this light and sound approach, we reduced memory loss in a very meaningful way, actually very profoundly. And the pandemic kind of interrupted our human study. Very unfortunately, MIT, kind of closed, and we couldn't bring the subject back. So we now also restarted our clinical study. We just, we enroll substantial number of patients already, and we are in the middle of collecting data. So yeah, it's promising. And the best thing is this device. So we use a kind of light panel, LED light panel, and a stereo that we install this device in the home of our participants, and then they, themselves or their caregivers would turn on the device for them every day, and they sort of treat themselves for an hour. Cognito Therapeutics, they have their own proprietary device, which is very different from ours. They use kind of like goggles, like device, and the striking thing is, their trial results and our trial results, despite using very different devices, totally different people, different patients, we saw very similar beneficial effects. That's very remarkable too, in my opinion.